weren't necessarily getting out maybe as much as they could to other working groups. And so I think that what we're talking about here is a different organization that's kind of set up to be led by individual working groups that might promote or kind of start off with some flash talks and things like that of what those working groups are working on. And this kind of a format would give us a way of having other working groups be involved and comment kind of early in the process as a better way of informing across the different working groups on what collectively or the individual groups are working on that might benefit from interactions from other groups. And so the permafrost hydrology, we're now the permafrost hydrology and wetlands working group. We uh, after the last workshop kind of met and decided that we had enough overlap in terms of the kinds of things that we were working on that we would join together in this activity. So we're now the permafrost hydrology and wetlands working group. This is led by Melissa Schwab, David Buttman, Laura Chavez, and myself. Melissa really kind of led the charge on this first effort as part of kind of this initial foray into this kind of new format. And so I'm kind of wearing Scott's hat in this particular um, meeting, but kind of what the format we want to take here is really for this particular meeting to really promote collaboration, cross-disciplinary synthesis across working groups. But our focus is really for this particular discussion going to be focusing on comparing and harmonizing aquatic products. And this is a topic that came out of the last workshop breakout discussions for the Wetlands and Hydrology Permafrost group from the San Diego workshop. And so, but in terms of the general format that we're going to follow here, what we thought we would probably do would be to just kind of talk about, start off with just updates from the project office. And we've had a few, and then if there's anything more, we can bring that up here, and then we can kind of briefly touch on updates from any of the working groups if they have any announcements to make. So what's a little bit different than the normal format we would have had is that we'll spend less time kind of going around to each working group and just really, as a working group lead or whatever, if you have announcements to make, you can make that here. And then we'll move on to, we have a flash talk scheduled for today. Laura Bergeau Chavez was going to talk about some of the recent work that she did as part of her project activities and comparing and analyzing soil moisture and water databases in context with her fire project in peatlands. And then after that, it's kind of an open discussion where we really want to talk about this a potential synthesis activity on this harmonizing aquatic products idea, and I can kind of lead that discussion after our presentation. So that's just kind of an open-ended format that we have starting off here, and I'm sure we'll modify it as we kind of move through this. But the idea would be, each month a different working group will get up and kind of lead the discussion in terms of the various things that they're working on. So bear with us on the first foray here, but just to start off, I know we've had a few announcements already from the project office. Is there anything else that anybody wants to announce from the office at this point?
I could say that we're trying to find a time slot for the ABoVE science team meeting next year, um, but I don't have anything concrete on that. All Scott and I need to talk soon on some of the things that we had talked about. Uh,
What would the general time be as far as a month? Are you
we were
looking at
actually
here?
thinking May,
May, okay.
um, but I think there's too much up in the air to say much more definitive about that. Scott, even if you have a better idea, I still need to run some info past you that I got.
Um, yeah, it's mostly Peter and myself, and we were thinking about doing it in Flagstaff, and we got an estimate for a venue there, which is quite nice. And for any of you involved in the Permafrost Carbon Network, we had a meeting there a few weeks ago, just before the Joint Science Workshop, the NASA Joint Science Workshop. And so we're thinking about that in mid-May, I think maybe the second or third week of May.
Great.
And that's just before Memorial Day weekend. So people who want to go like do the rim to rim in the Grand Canyon, prepare for that, you know, start working at beforehand. So yeah, that's the current thinking, but we haven't got an official bid for that yet. And yeah, and I guess I would say that we're open to thoughts on that. Um, it's not it's not hard to get the Flagstaff, although there's only one airline that flies in, American. But there's lots of airlines that fly into Phoenix, and you can drive up and down. It's a 2-hour drive. So yeah, we're open to thoughts on that, but that's our current exploration. Something new and different, something other than, I mean, we'd all love to go back to La Jolla, and that will probably happen before the end of all this. But
Yeah, I hope
yeah,
so. Although that space is hard to nail down.
yeah.
Great.
So that's that.
Does just a touch on summer activities. Has there been any issue with restrictions on travel or field work or airborne activities because of the fires at this point for Alberta, BC?
There isn't anything that would affect Avarice, directly because of the fires that are that far south. Now, as you all know, whatever happens in Alaska or in Canada further north, in Yukon or in NWT could really affect operations. But that smoke seems to be affecting the east coast of the U.S. more than it is.
Yeah,
uh,
it's getting us too
yeah.
in Montana.
So
Nancy, did you want to say something?
yeah, we had a note from our partners, Ducks Unlimited Canada, who works a lot with the um, communities in NWT, and Hay River had to have some evacuations
Mm.
and people leaving, and so community meetings and such have been disrupted, and that's going to change some of what happens in our program. But yeah, so there are some communities that are being affected that we should be thinking about.
Okay.
I didn't notice if Chip was on the line. He and I have been talking about having at least one of those office hour sessions to talk about what Avarice is doing this year. And I think everybody knows that the L-band SAR is planned for 2024.
Okay. Great.
Yeah,
In fact,
Avarice will probably
I'll
be the
drop a
most
link into the
challenging.
chat with sort of a draft of what I have on the ABoVE website.
Excuse me. Between my coughing, I was just saying that Avarice is going to be the most challenging given the smoke conditions, but that's nothing new.
Yeah.
The last time we flew was the same situation. Between clouds and smoke, it was extremely challenging.
Yeah, I think we've got everything right now for contrast between Alaska and Western Canada.
Yeah, and so I'm not officially project office, but I will say that I'm really glad you're doing these meetings and sort of mixing things up a bit. It's going to be nice to sort of, as you said, John, sort of spread it beyond the working group leads, which the intent was in the past that that trickles down to the working group members. But yeah, meetings like this, anyone and everyone can join and hopefully will. And it'll be nice to sort of get some perspective, ideally mostly from early career folks, but I think everyone's welcome to just present on whatever recent results there are and get feedback.
Yeah.
So I'm glad you're doing it.
And just
Well,
one other
just
thing
to
I think I would add is encouragement on the project office side. Liz has some great plans for the interns in terms of pulling together some of the ground observations that have been collected over ABoVE, uh, and um, and also getting the sites and measurements up to date. So when the interns reach out to you, please help them out. They don't have a whole lot of time to get the work done. So anything you do is much appreciated.
okay, great. So just to move us along a little bit, do we have any updates from any of the working groups as far as activities, announcements? I can go down the list, but I figured it's easier if anybody has anything, they could announce it.
This is Don Chen. I'm the leader of the disturbance working group. So we have a manuscript. So the database that will compile, which compile the existing field data in Chandra collected over the past several decades. The data set's already kind of pre-released by the DAC, and the manuscript we are looking at the submission day of late this week. So we're gonna submit that to Earth System Sign Data. Um, that's the that's our current status.
Okay, and you said the database is already out,
Yes, you
loaded?
have
Okay,
the data is actually out there. Yes, that's something I plan to work on this week. Everybody can actually download data right now because it's open for they say like final author like approval. I don't know about the terminology, but for some reason they haven't sent me the like final confirmation to that. I mean, but everybody can access the data right now with the DOI link. So I plan to just touch base with the DAC soon to find out if they have a date for the final release. And at the same time, I can share the link with everyone. I plan to send out the link to the entire BioF community soon, sometime this week. But I can share the link right now in the chat after
okay,
my conversation is done.
great. Thanks, Don.
No problem.
Is anybody here from Carbon Dynamics?
Hi, I'm here.
Ah, great. Hey, John. Did you want to say anything about the synthesis paper, the respiration productivity?
Yeah. So Abhishek has been working on this carbon synthesis project for the last little while, since phase 2 for sure. And he's been pretty overburdened since he moved to JPL, so it's progress on that synthesis has slowed to a crawl. But we're getting ourselves sorted over the next month or two to try and pass that off to somebody else. My bet is that it'll probably be me, but if someone else somehow steps up, it might change. But anyway, we're trying to get that out the door this year. I think that'll be really great because it's been going on for a while. Other than that, there's a carbon synthesis, sort of CO2 amplitude synthesis that we're keeping our eyes on. I think it's still sort of in the beginning phases, so there isn't too much to say about it in terms of results, but yeah, we'll learn more about that at some point later this year too. So,
Okay. I think is that the one that Jiwa did?
yeah,
Okay. Yeah,
yeah,
I think they've got, they're trying to push for an extension on the submission deadline for that to something like July 15.
okay,
So I saw the draft, but it's, people are just starting to refine it. And I think it's going to take another week or two at least.
yeah. That's all we've got. So, kind of a things are coming, but not here yet.
Okay. Josh, modeling.
Yeah, I'll just share one slide. The modeling working group has been very active. We've been having a monthly seminar workshop series. This has been our calendar since the January kickoff from the San Diego all hands meeting. So we started off getting into ILAM, which is a benchmarking system So that way the modelers can compare validation metrics and scores and kind of all point to a central place that we can go to for that. And so there's a bit of spin up in terms of, everyone's model is different, interfaces with the ILAM system a little bit differently. So, but that was good. We got people working on that and reporting back results, which will be useful as a foreshadowing to the end when we show improvements to the model relative to those initial results. So this provides this benchmark of baseline accuracy or skill scores that hopefully will get improved on over the course of phase 3. So that was really good. We also then got into talking about how to run models using common protocols and common forcing data sets for those who want to do that, using something called the WARP MIP, which Debbie is part of and helps lead, Debbie Hunsinger, and kind of a next evolution of the MISTI MIP that she led for many years. Then we started getting into functional relationships, which is critical for connecting this wealth of data from above that have been collected over the first 2 phases, especially when it's a bit spotty with like flight lines here and point measurements there and flux towers there, and how do we actually interface that with wall-to-wall gridded models, which a lot of the models are. They're not all like that, but most of them are. And so we're talking about these functional relationships, which is basically how one variable relates to another. What's the mathematical relationship? Is it linear, nonlinear? What does that look like? And then what does that look like within the models? And as a means to scaling these spotty measurements and of different resolutions as well. And as also a means to have efficiency, given that it's a bit overwhelming, the amount of data that's been collected in ABoVE, where to start from the modeling point of view. So we sent out a survey to the modelers on what are the top 5 functional relationships, these variable to variable relationships, modelers think are most important or lead to the most uncertainty or error in the models. And then we are starting to interface the data from ABoVE that match those relationships back into ILAM, and then using that to really hone in on our metrics and our validation exercises. The June meeting coming up in a few weeks, we're going to focus on just kind of a lightning talks. We've been doing a lot of discussion of lightning talks in ABoVE, but things that we think other modelers might be interested in for development in their own models, whether it's an isotope thing or a new permafrost thing or a new disturbance module and so on. So I will be pinging the entire ABoVE team beyond the modeling working group. If you have anything that you think the modelers might be interested in terms of, including in their models, we want to get, a slide or two, or just a couple of minutes, just to let us know. So I'll send out that information soon. And then we've got the schedule going on for the rest of the calendar year. So that's been what we've been up to in the modeling working group.
Great, thanks.
Hey, Josh, do you have a date for the June meeting yet? Today's the 4th.
The June meeting is... What is the June meeting? I need to look at my calendar. It's on the 15th. It's
yes, it's the 15th.
15th at 11 a.m. Pacific time.
Okay, thank you.
I'll send that in the email too, in the Zoom link.
Great. I'll just quickly from the hydrology and wetlands group. So we've been working on the hydrology permafrost group had been working on still finishing up their phase 2 activities, and they did get we've got basically one paper submitted on that. That was the active layer upscaling activity using the airborne radar legacy lines. So that's in review right now. And then there's a second one we're working on that had been more of a Pan-Arctic focus, whereas the first one was more of an Alaska extrapolation. And that's, I've seen the draft. It's pretty close to being ready for submission, but we're hoping to get that out before the end of the month. And did I don't know if Paul or Matt are on. Did you guys want to say anything about vegetation dynamics?
Hey, so this is Paul. I have just a real brief announcement about some vegetation structure working group stuff that was part of phase 2. It's now kind of rolled into veg dynamics in phase 3. So part of our work for phase 2 was preparing the Elvis flight lines for gridding them, and then using them to examine growth across the above extent. And so our paper doing just that has been provisionally accepted at ERL. So this is potentially useful information for modelers. So Josh, maybe we can chat or something at some point just in response to what you said. Again, it's sort of regional statistical summaries of general forest growth with their uncertainties. So these summaries help, in theory, help modelers play statistical games with how growth can vary in forests within regions. So that's a summary of this paper that's been provisionally accepted. And that came out of the veg structure working group work in phase 2.
So this might help, say, models with that are trying to track cohort changes post-fire, those kinds of things?
Potentially, yeah. And so
Structure.
this work was done kind of in communication with Amanda Armstrong's a co-author, and she runs a high-resolution model. And it was also done kind of in communication with Leo Kaye, who runs LPJ. So while I understand that there's a lot of ways to kind of handle vegetation growth in all these models, the results of this paper may provide one type of useful input for some of these models. It really depends on what questions you're asking, but the potential might be there. So it could be of interest to modelers.
Did you say the database, is that ready to look at, or is it still?
So the kind of like the database that comes out of this is basically a statistical summary with uncertainties. So it's a summary of growth by region with uncertainties. So it's a easy to manage table. And so how people use it is kind of up to them. And also if it's useful for them, it kind of depends on their questions. And so that'll be published with the paper, this little table. So anyway, anyone can talk to me if they are interested.
Yeah, that sounds good and interesting, Paul. And also, I'll write in the email if you can't make it to the meeting or you don't want to come to the meeting, but you want to send a slide or two or like a video of you presenting the slide, then I think that'll be useful too for, not just you, Paul, but for anybody. But what you said sounds very interesting as well.
Cool. Thanks, Josh.
Yep. I got one more update. Is this sort of a joint effort with the spectral working group. It's to make the entire above average collection sort of analysis ready. And so we have working with initially JPL to reprocess using a consistent surface reflectance baseline for the entire collection. And then Wisconsin will do a BRDF and terrain correction. So sort of the state of the art, but applied across all the years where the data has been collected. So one of the issues is that the processing changes from year to year in the data that's there. And then the final step would be a conversion to an analysis ready format that will be optional, but it will expand the software packages and the number of users that can use this data. And our objection then is to develop vegetation composition products that can be applied across the entire Avarice collection and not just a single site or something like that.
Great. Any other comments before we move on? Okay, great. So Laura, are you on? So we had a flash talk schedule, but I'm not sure it was Laura was going to give it. I'm not sure she's on. I did send her a ping, but
Laura had to go because she had a family emergency yesterday, and I'm not prepared to do this.
Taglia. I have a flash talk that I had put together. Laura said that she might be out. So, but yeah, I can give a brief flash talk. So what Laura had asked me to put together were some slides about the inundation products that we have been generating for Nancy's project. So I am prepared to do that. I don't know if that was exactly what Laura was going to present on, but that was what Laura had asked me to talk about. So
Okay,
I can
great.
briefly if that's all right.
Yeah, that sounds good, Mike. I think you can grab the screen.
Okay.
Might need to make him the presenter. Hold on. Did you get it? Okay, good, cool.
Okay. Yeah, so I'll try to keep this brief. I know it's supposed to be a flash talk, and I tend to be, I don't know if any of you have seen me give a talk before, I can be a little bit long-winded. So I'll do my best. And I know that a lot of you have probably seen some of this work because Nancy has presented this quite a bit over the past 6 months or so. But I wanted to go through this, especially in the context of NISAR going up next year. And I know that there's part of Nancy's phase 3 project. We've been thinking about how we can collaborate with some of the other ABoVE researchers as well as people in the community. So kind of go through this pretty quickly. So the primary goal of what we've been working on is using synthetic aperture radar to monitor inundation extent across the ABoVE domain. And so if anyone is not familiar, I know we have some interns on synthetic aperture radar. Sensors are active microwave imaging systems, and they can provide observations in most weather conditions. Sometimes you see people say all weather conditions. I'll say it's not always the case, but most weather conditions, we can get good observations and we can collect data day or night. Currently, we have C-band Sentinel-1, which is pretty high repeat observations over the ABoVE domain. And the reason that we use synthetic aperture radar is because it really has a lot of sensitivity to hydrologic conditions and vegetation structure, which allows us to assess the inundation status during the growing season. And so for our purposes, for Nancy's project, we've been looking at using these output inundation products as inputs for waterfowl abundance models. And we're planning to incorporate these products into some other applications as well. And so thus far, we have semi-automated algorithms that have been implemented. We do that locally via Python. We also have those in Google Earth Engine, but we're also working on implementing those in sort of an AWS cloud computing environment in preparation for NISAR. As we understand that ASF is going to be serving up NISAR products via AWS. So we're planning on that, and we're getting those algorithms set and ready to go. So this is just an algorithm overview. Kind of no matter what we're looking at, we can kind of sub in different sensors here. So this is specifically for Sentinel-1, but we can do this for X-band data. We could do this for L-band data. We can do this if we have horizontal send as opposed to vertical send data. You can see that in the third box here, we're using VV and VH, and what that refers to is the polarizations. And so in the case of Sentinel-1, we're dealing with vertically sent radar energy, and then that is being measured as it gets back to the sensor in both horizontal and vertical components. And so we use that information with some Atsu thresholding and some image clustering and image segmentation techniques to just generate some image segments. And then we divide up each of our images into classified regions that are either open surface water areas, flooded vegetation, or non-flooded regions. And then we can combine those products into what we refer to as relative hydro period maps that give us an understanding of how often each pixel within each image or each study area is being classified as inundated throughout a growing season. And this is an example. We kind of came up with this algorithm several years ago for the Great Lakes region. We were using RadarSat-2 data initially, so you can see we were using HV and then the ratio of HH and HV to come up with these algorithms. Now, we don't have access to RadarSat-2 all the time in the ABoVE domain, but we do have Sentinel-1, so we just were able to alter this slightly. But you can see how that generally works, where we come up with on the bottom left, a surface water extent, so talking about open surface water extent map, and then on the right, flooded vegetation extent map. And so taking that same approach, this is one of our sample areas. We've done a lot of work in the Peace Athabasca Delta, and so this is the region that we focused on quite a bit for phase 2. And you can see this example from Sentinel-1, where we have this map divided up into flooded vegetation, open water, and then non-inundated areas in the gray. And then we can combine these together, and we have these relative hydroperiod maps where we have basically each pixel is classified as to how many times it was inundated, either as open water or flooded vegetation throughout the course of the growing season. So here you can see 2019, and then you can see 2020. So there's quite a bit of change between those two years, and we know that there is a big flood event due to some ice jams along some of the rivers in 2020. So that's one of the reasons that we see such a major difference. We've been using these products, the output products, for waterfall modeling. And really the big takeaway here is that when we use this time variant data, we're able to see quite a big improvement as opposed to just using land cover maps, for example. So we see deviance explained almost doubles when we incorporate this time variant information by having these repeat overpass Sentinel-1 inundation products, which we think is pretty cool. We do have a product validation protocol that we go through. Now, this was really hampered by the pandemic and the limitations to accessing the sites, but we have done these for some limited areas and got good results. The area that you can see there is where we have those transects run is actually in the Great Lakes, but it's generally the same approach that we use where we walk along transects from dry land through the wetland vegetation until we get out to the areas where there's no longer any emergent vegetation. It's just open water. And that's how we classify how well we've done by creating these products. And then we've also been collecting multi-frequency SAR. As I mentioned, we're preparing for NISAR, which is still scheduled to go up next year. Fingers crossed that goes up on time. And we also have increased access to commercial X-band data. And so we did this fun little comparison here looking at X-band in the red channel, C-band in the green channel, and L-band in the blue channel for 3 separate dates. And so this is really an amazing data set because we're able to get these 3 different collections at 3 distinct times of the year throughout the growing season in June, July, and in September, which is really amazing. And so what we can see here is that we see different responses. And so X-band obviously being very short wavelength, C-band being in the middle, and then L-band longer wavelength. We're able to see some distinct differences. And this is really driven by the vegetation structure and biomass. And then one of the things that really drives this as well, in addition to the biomass and the structure of the vegetation, is the water content of the vegetation. And so in early September, when everything starts to senesce, because of the physics of all of these interactions that are going on, you get less backscatter as the vegetation dries out. And so in early September, you see a dampening of that backscatter effect from those at all of the different sensors. But what's actually interesting is that you get such a decrease at C-band because of the polarization. There's a Brewster angle effect that's occurring there, specifically with the vertical polarization data. And so when we classify the flooded vegetation extent, we actually don't get any areas that are being classified as flooded vegetation in early September at C-band, and that's because that's vertically polarized as opposed to being horizontally polarized, and that's just the physics of it. I'm not a physicist, I'm a geographer, but I understand this stuff well enough now to know that's why the C-band observations are failing us. But anyways, I think this is a good example of how we're planning to look at things moving forward, and we do have a good understanding of how these products can be used, and also though see the limitations that we have here when it comes to the different sensor types. But we are really excited for NISAR to go up and continue to be able to use the C-band data, and then also hoping to expand this to other applications. I know that we're currently working on some products for some other ABoVE collaborators, which we're excited about, looking at some areas along the North Slope of Alaska, and then working with some other folks from the government of Canada to try to develop some more of these products for different areas. And we'll continue to do so as we move on into the coming years with NISAR and hopefully some other cool sensors as well. And that's it. Hopefully I didn't take up too much time. But if anyone has any questions, you can feel free to ask now or shoot me an email.
Hey, John, I think you're muted.
Thanks. I was talking to myself. Are you, Mike, are you using the NISAR formatted Sentinel data for your algorithms?
I have not used that yet. I was not aware that there was Sentinel formatted NISAR data. We've used some of the
Or
UAVs.
NISAR formatted Sentinel data. Yeah.
Yeah. We've used some of the NISAR formatted UAV-SAR data, but not the Sentinel data yet. But that would be very useful. As everyone knows who's dealt with any type of remote sensing imagery, the formatting is a challenge. But
Yeah.
no,
Just thinking ahead to NISAR, it's a bit of a different format
right.
for us to get used to it. So that was a nice, if you go through the NISAR science team webpage, you can get access to those data, those early data products. And that might be something to look at anyway. And
Yeah.
my second part of that question was the L-band data you're using. Is that ALOS?
So I should have mentioned that. Yeah, thanks for bringing that up. I had two images that were UAV-SAR in that comparison. So I think I can go back here real quick. So yeah, two of the images are UAV-SAR, and then one of them is ALOS 2. Yep.
And are they contemporaneous in time?
All of these are within 4 days of each other. So the mid-June, I think it was from June 12th through June 16th that we had the XC and L band. July and September were the same. I think the July dates were within 2 days of each other. So they're all pretty close there. So there were some minor differences in the time frame. But we did also correct these for incidence angle to try to remove some of those incidence angle effects just for the visual comparison going from UAV-SAR, obviously with that really wide incidence angle range compared to the ALOS 2 data, which is pretty small in comparison.
Okay. And it's, so are you gridding it then to 30 meter?
In this case, yes. So for these visual comparisons, it was gridded to, actually it was to 12.5 meter, which was the ALOS 2 um, resolution that we had. So this is 12.5 meter, and they were all just kind of pinned to that 12.5 meter grid.
Okay, great. I think it's a nice example. I think in terms of, you've got this emergent vegetation in wetlands, and so you'll start to lose sensitivity maybe at the higher frequencies, but that tends to be compensated by the low frequencies. And so the combined observations of this multi-frequency SAR give us that added value.
Yeah, I think that it's really really fascinating looking at some of this stuff. I mean, I've been working on SAR data for 10 years, and this is the first time that I've had access to something that was this close at 3 frequencies. And yeah, it's very enlightening seeing some of the differences and comparing this to some of the land cover maps that we've generated as well provides a lot more insight into what's actually going on. Obviously, you expect to see higher backscatter at L-band when you're in higher biomass regions, and it certainly looks that way when you're looking at some of the emergent vegetation, especially up in this region where it's really things like bulrush that are very low biomass look almost invisible to the L-band sensors, whereas at X-band it's really a strong bright signature. But the polarization also really really interesting, and so it's as valuable as some of this stuff is in terms of providing products. I think there's also a lot that can be done in terms of research in terms of scattering, because there's still as robust as that field is, there's still a lot more to be learned when it comes to wetland vegetation specifically.
Great. Any other questions? So I'll just add, so Mike's talk gives us a good, just an example of the kinds of things that we as a group have been talking about. And part of that, as I mentioned earlier, started with our breakout group discussion with the combined permafrost and wetlands working groups at the last ABoVE science team meeting. But the where we kind of laid out all of the new projects that were hydrology and wetlands related, and looked at the common themes. And one of the aspects that we found was that there are different groups that there was a common thing of being interested in these surface water products that characterize lakes and wetlands, surface water trends, surface water inundation dynamics, um, but at different resolutions, and ranging from kind of these field scale assessments, inventory assessments of long-term changes and crow flats and other particular, localized areas, to other groups that were using various remote sensing approaches to try to use surface water bodies to scale methane emissions and things like that across larger regions. So there were different resolutions, different platforms, different sensors that were kind of being used. And when we kind of looked at these, some they don't always agree, depending on the different particular products that we're looking at. And this Mike's talk here is a good example of that. Just comparing, different frequency radar observations, you can get a different story just based on how the land surface is changing over the season. And you could extend this to even the optical realm in comparing MODIS and Landsat versus radar. We can see different things depending on the length of the record, the spatial resolution, the domain. All of these factors kind of come into play when we start dealing with, what are the distributions of water bodies? What kinds of water bodies are we talking about here? And how can we kind of gather these and reconcile some basic linkages across the data sets that we have available to us? And you might notice when you go through the ABoVE data products that are already archived, there's a number of kind of potentially complementary wetlands, lakes, and water body trends data records already there that are potential assets to doing some kind of a combined activity where we might start to look at things like doing some comparisons to try to get at some maybe larger science questions about what the patterns and trends in surface wetting and drying would be. What are the underlying drivers of those trends? How reliable are those trends? Do they all say the same? Are they all going in the same direction across the region? Do they show similar gradients spatially? And if not, why? And we kind of looked back further and kind of looked back to the original experimental plan, and this goes way back. This idea in terms of one of the tier 2 science questions from the experimental plan, we're really trying to look at causes and consequences of changing surface hydrology, with particular focus on the distribution and discharge and amount or abundance of surface water and subsurface water dynamics. And so with that in mind, one of these kinds of tasks we had thought about was, can we just start with a general comparison of these kinds of things? And given the different sensors, frequencies, active, passive, optical, microwave, look at pick a domain and do a deep dive into what we're seeing in some of these surface water trends. So potential products that we could look at here could be things like, Landsat. We've seen several papers come out, but there are several different types of Landsat water records. There's the Landsat JRC record, which is on Google Earth Engine. There's the Dynamic Surface Water Extent product that the USGS produces. There's now the newer Mod 44v6, Mod 44W version 6 product. There's passive microwave data sets for fractional water. For certain regions, there's these higher resolution radar products that come into play. There's higher resolution Avarice and other optical type observations as well. And in certain areas, we have really detailed ground observations, and Mike kind of alluded to that with their particular study in terms of what they're using for ground validation. And there are some other areas where they've done really detailed assessments that may also include things like long-term changes from historical airborne imagery relative to current imagery. And that's some of the work that Ken Tape's project has looked at in terms of beaver engineering across central Alaska. So there may be areas where we want to do a particular focus area, or maybe we want to focus on a pan-Arctic wide or above wide kind of domain. But these are, all kind of on the table for us as a group, thinking about these participating projects and the kinds of resources that we have on hand of how we might approach this. But you can see that this, has obvious linkages to wildlife, as noted with Mike's link to aquatic waterfowl. But there's links to beavers. There's links to aquatic habitats, freshwater delivery to coastal communities. These kinds of things all have cross-cutting linkages to other working groups. So that's an idea. There are other things we could focus on, but this was definitely something that rose to the top and had a common theme across participating projects coming out of that last workshop. So with that, I'll leave it open to discussion. Does anybody have any comments, or does this sound worth pursuing? Is there interest? For particular projects, one thing we thought we might do, I don't know if is David Buttman on. He had to teach, so I'm not sure if he was able to make it yet. But
doesn't look like it.
Okay, so David's project is focused on linking landscapes and aquatic ecosystems in boreal and Arctic lakes. As part of his project, he actually is going to be putting together aquatic database, lakes and aquatic database for methane assessment. And so that's, we have several projects like that kind of require these types of databases. And so I would expect that those projects might take a leading role in helping to organize something like this. There are, right off the start, really kind of starting as with just an inventory of what we have available to us for these water products, and coming up with a simple table might be a good starting point to help identify domains, spatial domain, a focus area, and then the kinds of data we might look at, and then the kinds of ground data we might have available for some kind of an assessment. But that's really as far as we've gotten in terms of the thinking here.
Cool, thanks. Yeah, I think this is really interesting. Just as a heads up and maybe something to think about until we meet again is I had a little bit of a discussion with Ted Scher about possibly if we do the 10th ABoVE science team meeting in Flagstaff, to do that jointly with the permafrost carbon network, which is also morphing into something somewhat new and different. So it could fit well with permafrost hydrology, wetlands type theme, and help facilitate interaction between the PCN and ABoVE activities. There's a bunch of people who are already involved in both, or at least a number of people who are, but this might help move that along.
Do you know if they've already scheduled their meeting for a similar time and location,
Not for next year. They just had one this past May. as I think I mentioned just before the NASA Joint Science Workshop in College Park, they had one. They had the Permafrost Carbon Network meeting in Flagstaff.
Yeah, several folks involved with the current working group are participating in that as well. So it's an obvious
Yeah, could
area
be good. I mean, there could be
opportunity.
other
Yeah.
working groups that, you know, that might want to, depending on what sort of networking activities different working groups have or involved in. The Permafrost Carbon Network's an obvious one because it's been going on for quite a long time. It could also be quite a good one to do a joint meeting with.
Yeah.
But if there are others, you know, modeling, I guess in particular, comes to mind. Bringing in other people from different modeling coordination activities that could be productive.
Yeah, I think modeling is going to be pretty critical because particularly on the scale aspect, you know, the how well do the models agree with each other, you know, the trendy type models or from a hydrologic perspective. And then, you know, are they consistent with the kinds of observations that we're seeing? And I know there's a lot of differences in the kinds of observations we're seeing in terms of wetting and drying and where and the magnitudes and the rates. Um, you know, so the kind of this bottom up and top down assessment would be interesting to look at. We could do that from a, you know, an observational standpoint, but it would be nice to also make a link there with the modeling since since this kind of surface hydrology trends is really kind of, you know, has obvious carryover to carbon and other factors, climate as well. So it would be a nice way to use the modeling to make a linkage. And we had Chinlai Zhang he's got a modeling project that is looking at hydrology, permafrost, ground ice, and land cover changes across the region. So he was kind of our representative modeler at that breakout session. And the nice thing about the models is they can kind of handle, you know, they can reproduce what an observation might be seeing, but then they also have this nice linkage to all these other factors, a full water budget, for example. So it really does help to make attribution to what we're seeing from field and remote sensing. So having that representation would be critical. So so with that, I'll just leave it that if anybody's interested or has thoughts on this, just send us a ping via email, either myself, Melissa, or David, or Laura, and we'll kind of assemble a plan of action. Well, we're at the top of the hour. That's it for us. If anybody, unless anybody has any final comments to make. All right. Thanks, guys. Talk to you later.
Thank you, John.
Bye-bye.
Thanks, John.
Thanks, bye.